Thanks, Cassandra, for the intro, and thank you guys for staying late on a beer o'clock Friday afternoon. Gives me a lot of confidence about your life choices, but nonetheless, my name is Ravichandran. I'm CTO at Narvar, and in this talk, I'm going to go through Narvar's data journey. I'm going to, bear all the mistakes we've made over time, and hopefully I can rationalize for all the mistakes I've made over the past few years, and then I can probably tell you where we are today. Before we go ahead, maybe as Cassandra was mentioning, I wanted to give you some background about what Narvar is, what we do today. So we are a B2B SaaS company for retail. We allow our retailers to provide personalized experiences for their customers based on their data. So you may wonder, what exactly do we do there? It's basically a data play, right? So we take all the disparate data sources that our customers have, so our retailers have. So this would be data from the order management system, from the customer relationship management system, which tells information about the customer themselves, the billing information, any calls they've made, the fulfillment centers, what the inventories there are, the carriers, which has all the carrier data on what orders are getting shipped. The warehouse management systems, and we take all this data and we create a unified view of the customer and a unified view of the orders. And using this unified view, we are able to create a whole bunch of white labeled experiences, which start from the pre-checkout process. So if you go to Costco today, and before you hit add to cart, there will be a little snippet that says that if you order by this particular time, it will get fulfilled by a particular date. That's powered by us. All the way up to when you place the order, all the order notification that goes on, shipment confirmation, and then if you go and you want to check the status of your package, all that's run by us. And similarly, you go through the entire process and then you decide that you don't like the item you've received. When you go online to Gap or Nordstrom and you do the returns, that is actually our portal, which is white labeled by those services. So we're kind of the back end for many of the larger retailers. We have over 600 retailers and brands on our system. And we are actually a global company, and we've got offices around the country, around the world, but also we have large retailers in each of these different countries. Just to give you a good idea of the scale we're talking about, we have about 125 plus million unique users who come to our site regularly. And again, when I say our site, it's all these different merchant sites because that data is being served by us. We have about 6 billion plus data operations per day. This number is probably much higher now, but at some point in the past it was at 6 billion data operations. We are in retail, which means that bulk of the activity happens in Black Friday, Cyber Monday, and other times the peak can go up to 8 times the traffic, right? So we have very, very bursty traffic. In this talk, I want to go through three different parts of it, three different acts, so to speak. So first I'll set up about what our history is, and then the issues we face, and then how we solved the data issues that we have, or data on the data store side. So like I mentioned, we have disparate systems, like many of systems in our industry, we have a mix of document stores and relation data. So things like the carriers will tell you the statuses of the package over time. That comes as a huge document to us for us to process. Things like similar call center, that huge emails that angry customers write, that comes to us as a document. And then things like the order management, the items in the orders, the returns, all that is transactional. So we have a combination of both types of data. And when we started in 2012, we started where everybody else starts, and I think where everybody should still start, which is a Postgres, which was a decent-sized Postgres for the money that we were able to put from our own pockets, which we thought will scale for a while. And then soon, of course, we had to buy a bigger instance, and then we kept all the document stores as JSON blobs, and then we kept all the other relationship data as tables. And then at some point where we hit one of the maximum size nodes that Amazon provides, and we're pretty excited that we were scaling well until we were not scaling as well. We were just starting to hit all sorts of limits. And then this is when we were like, okay, maybe we should go hit the books, figure out what we need to do. Of course, we do what everyone else does and goes and vacuums the hell out of it, and then figures out, oh, so that's probably what we need to do. And then let me see what these settings are, and let me go play with the settings. So that worked well until it didn't, right? And then we're like, all right, we go do what the next thing people do, which is put a cache in front of it, because that solves all the problems. And that worked well until it didn't, right? And then we're like, all right, that also is not working out. So we then started sharding. We took the smaller tables out of it, put them in separate tables, and we said, by this time we knew things were not going to go well, so we decided to just go into RDS and figure it will become Amazon's problem. And we did that until we didn't really scale well there. And then it turns out we were still sitting on a 9.3, so they said you should just go to a 9.5. That's going to solve a lot of the problems because we have a JSON-B store that will be available, and that can help you index much better. We're all great, we're all excited, and they said, oh, one thing, before you go to 9.5, you got to go from 9.3 to 9.4, and then we'll do 9.4 to 9.5. What do we care, right? It's going to work, someone else's problem. Turns out it wasn't someone else's problem, because when we went from 9.3 to 9.4, the damn system locked up, and we were stuck for a few hours, and the support folks said, it was really great, but they said, well, we can't do anything about it, our hands are tied. Let's wait till all the data moves from your old system to the new system. And then Amazon was like, yep, great, now it's all working, we're excited. And they said, now it's time to go to 9.5. And we said, no, thank you. We're happy with 9.4, we'll stick there. And then that's when we said, okay, let's start to get into this NoSQL business. Back in the days when I was at Twitter, we had started using Cassandra. And there we had a MySQL to Cassandra problem. And back then, Cassandra was actually probably released by, were you at Facebook at that time? Yeah, and so the Facebook guys had pushed over Cassandra, and we were like, dude, Facebook is using it. It should be good for Twitter because Twitter is smaller than Facebook. Little did we know that Facebook decided that they really didn't want to use it. Hence, they pushed it over the system. But we caught it, and then it became our problem. And so ever since that experience, I was very, very afraid of using anything NoSQL, just because I knew we had to change the way we write. Every time we change any access patterns, we need to change the data structure. So I was very hesitant. But then we said, okay, let's go put some of the documents inside DynamoDB, because that seems to be what everyone else is doing. Though this time we knew it's not going to be Amazon's problem. So that was one thing that we knew from the previous experience. And actually, it worked really well, right? So we had this monolith, which is talking to DynamoDB. It was so easy to migrate, and we could get shit done, which is amazing, right? Especially when you're a startup, that's what you want to be doing. And they have very good support for the different data types. It scaled very easily, both in size and throughput, and no maintenance. We're actually surprised. And the uptime was just amazing, right? And this is partly because we were coming from the RDS side of things, and this was really, really great. And of course, we decided what every grown-up company does, which says, okay, this monolith should become microservices. And we said, okay, let's go do that. So we did that. And then suddenly, our costs started to increase enough that our CEO was asking, maybe we should be in this database business rather than in the retail business, because you seem to be spending more money than we make. And so we said, okay, let's go look into it. And then turns out what was happening was all these different microservices were hitting the different partitions. And when a new data comes in, everybody wants more information about that one particular order or that particular tracking number. So even though the tracking number was a very good key to shard upon, you really, all the queries were going to the same partition. And the way Amazon scales is that the hottest partition sets the multiplier that every single partition gets, right? So if one partition has a key that everybody's using, and that goes to 10x the capacity, then all the other 1,000 partitions, and by the way, partition size is about 10 gigs, and we're talking of terabytes here. Suddenly every single partition gets 10x the capacity. So you're paying for all this different increase in capacity that we never wanted to use in the first place. And so the cost was starting to become nonlinear in increase, right? Then the other thing is that we always needed GSI just because we kind of look up by more than one index. Sometimes it'll be a tracking number, sometimes the order number. And that started to become very, very expensive, and was also not strongly consistent. And the problem was that when we send out communication, sometimes we send out by email, sometimes we send out by SMS, sometimes we send out by both. And then because they were not consistent, we would guys will get different delivery time. One will say, yep, it's out for delivery. The one will say that it's all in front of your door. I'm pretty sure you guys have seen that when you got deliveries. And the other thing that we did not read the fine print on the pricing is that the read units and write units are metered per kilobyte, not per query. Makes a lot of difference when you have those long, angry customer emails. We were paying for every single word that person was writing. And then the backups. This is the other thing, and this is definitely our mistake. We were doing backups like the way we do at SQL. Turns out that doesn't work, because as the database started growing, all the backup times were going from hours to days. And then DAX was great for caching, but was getting very, very expensive for what we did, right? So these were all the issues that we had. And then, of course, we are high-paid engineers in the Bay Area, so we'll go solve every one of the problems, whack-a-mole, right? Great. So we did that. We said, OK, you know what I'm going to do? I'm going to not use DAX. I'm going to put Elastic Cache in front of it. And that took care of the increase in cost due to the hot partitions. That took care of the GSIs, even though it increased latency a little bit, because now you're going to an external store, looking for the lookup key, and then coming back and doing a lookup here. And then we didn't even need to worry about DAX. We were kind of excited about this setup. And then for the kilobyte, we said, OK, let's go. It's this document. Who cares? No one's going to be reading it. So we zipped everything at the application, and then we did the store. So that definitely helped reduce the metering a bit. It also actually helped increase throughput a bit, so that was also great. And then we used DynamoDB streams for doing all the backups, right? So every time there's a change in the master table, there's a change data capture that goes through streams, get caught in a Lambda, then we'll write in a replica table, or we'll write it into the S3 store. So that was great. But it was still getting very expensive. And then one of the things I've noticed in the database community is that everyone talks about queries per second. What's the max queries per second? Was another max queries per second that the other database has? For me, as a business owner, I think in terms of queries per dollar spent, right? As long as you're hitting like between 10 milliseconds and 9.5 milliseconds, or even we'll see some of the stats between 2 milliseconds and 1.5 milliseconds, I can give two hoots, right? I can't even blink in that time period. What I do care is that when that query is costing me $1 versus like 10 cents, yeah, that's what I really care about. And with the rate at which we were growing 8x in DynamoDB spend, right? And this is just not something that was scalable for us. The other thing is that we have a very, very bursty traffic. And DynamoDB has this automatic scaling. And with that, it takes a minute for it to see, should I scale? Oh, it looks like you have sustained input. Let me scale. But by the time the guy has come, he's hit the refresh button 10 times. So it just didn't work well for us, especially on a Cyber Monday, Black Friday. It just does not work, right? Because everyone is waiting for that midnight to hit the refresh button to go place the order. Definitely not working out for us. But like any relationship, you're in the spot where you're too good to leave, too bad to stay, and you're stuck in this middle ground. By the way, it's a really good book, highly recommended by my ex-girlfriend. Helped her make the decision right. For us, we don't have a book. What we did have is Brexit and GDPR. So, we were a global company. We went to EU, and they said, well, you've got to rethink the way you do your encryption. What we did is we encrypted every single field by itself, and we would store, and then some customer would come by and say, delete all the data that you have by my email address. And we're like, dude, we can't even get your email address until we decrypt every information that we have. And that did not work, and so we had to do something called crypto shredding, which is basically take all the keys, take all the emails and all the different data, figure out a very unique key that you encrypt by, and then basically when someone says forget me, you just forget the key rather than going and rewriting all the data. So we need to rethink the way we did encryption and also data retention. Some of our retail customers were not okay with AWS hosting the data. EU guys wanted all the data to be in EU. The banks in India would not allow data to be outside India. So we now had to think of multi-cloud. So that was definitely something that became a thing for us, and definitely we can't use an Amazon-specific technology to move forward. So we said, OK, let's go start looking for a new data source, and so new data store. And so we had a few criteria. One, had to be open source, cloud native, multi-data center, Managed services available. Definitely don't want to make it our problem. We have a different set of problems to take care of. Also, we want it to be easy to scale, high performance, that goes without saying, and then total cost of ownership, like I said, dollars per query. And then for us, one thing is a lower variance is more valuable than lower mean. So low mean will get to a certain level, but the low variance is really what matters, because when you think of distributed systems, when you add distributions, the variances add up, right? And so at some point, if you have like 4 distributed systems and each one's adding a variance, you're suddenly thinking of seconds versus milliseconds to get some responses. So definitely low variance is where we value a lot more. So the initial set of choices were almost too clear. We'll just keep the Postgres from RDS to our own Postgres. We'll go from Elasticache to native Redis. One of the things we get with that is that Elasticache stopped allowing for fsync to disk. And so that's something we can get back. And DynamoDB to Cassandra, because hopefully by now more people have cleaned up Cassandra than just Twitter, and so it should be good enough. But we did some analysis, and then actually we ended up going with Yugabyte because they hit all the points that we had, and plus there are other things that, of course, if you go to a blog, and since you're here, you probably already know that Yugabyte is pretty strong at, and so we decided to take that bet. And this was about a year ago. So the next set of slides, I want to sort of share our experiences. And very clearly, one thing that we had a problem with was everybody had benchmarks, which was, like some key gets and puts, which is great. But we really could not find somebody who was using in production and sharing numbers. So we said, let me do this. My general counsel hasn't seen the slides yet. But let's go through it, and then later on, we'll deal with the fallout. So we've been running this in production for over a year. We've migrated about 20% of our microservices, not necessarily 20% of our data, but that gives you a gist of the migration we've done so far. And then the rest of the microservice we're migrating to rest of the year and maybe early next year. And then the main thing is that through last Black Friday, Cyber Monday, the systems ran really well. And this is basically a snapshot from our dashboard. I guess the Yugabyte guys have, as part of Yugaware, I think. I'm not sure what the name now is. But this is their dashboard, and they maintain it for us. So in this case, it's actually a 3-node cluster. I don't know how much you guys can read from there. It's a 3-node i3 2x large cluster, which is basically 8 cores each, 60 gig RAMs, and 1.9 terabyte NVMe. Pretty standard. Cost us about $2,000 a month to run this node. We've been this launch time says May 16, 2018. I think we started using in earnest maybe a couple of months after that, but still it's been over a year. And then very specifically, we only used the SQL, the Cassandra and the Redis part of the service. We had not used the Postgres side of the service in this setup. And then we have a replication factor of 3, multi-AZ, right? So that's the setup that we have. And these are some operational numbers, just to give you guys what we were seeing. We're seeing about 10,000 writes per second, 4,000 reads per second easily. And it's actually pretty consistent. Your read latencies, we were seeing about less than 2 milliseconds, 99 percentile. Most cases was less than a millisecond. And then writes were definitely less than 10 milliseconds. And again, this is pretty consistent. And then the CPU was about 40 to 50%, and it was pretty stable. Again, we've actually been super happy with the setup so far. So a few key takeaways. Your mileage may vary, so don't go make a decision and then lose your job and then come blame me for it. You should go do your own benchmarks. Nonetheless, if you're starting a company today, don't do anything fancy, just use what they provide. Very likely that's good enough for you to get acquired. We were able to eke out like a 4x cost savings here. In practice, it was about 6x, but then I think there was about a 2x that we just got from battle scars. Some mistakes we made before we never openly admitted, we went and fixed. So that was about a little bit of an advantage. But easily we would see a 4x cost advantage between what we got from Yugabyte and from using the Amazon hosted services. And like I said, we've been using this for about 13 months. One of the things I should point out is that we actually went from 1.0 to 1.1 to 1.2 while we were live, and it was pretty seamless. We didn't even notice it, or maybe someone noticed, but no one brought it up to me. So it's pretty good. And we're actually, one thing is at Narvar, we're moving all our internal queries to be GraphQL, and so all the internal APIs to be GraphQL. So I'm super excited about the distributed SQL, which we are hoping to try after the 2.0 release, and also make the database layer itself, talk GraphQL. Cool. That's all I had for you guys. Thanks again.